Hey, Science Nerds, and welcome to our second discussion in the Energy and the Environment unit. Today I'm going to be discussing topic 1.2, solar fuel from the past. Well, when we discuss energy sources here on Earth, there are a lot of different ones that we can use. I mean, mainly we've been using, combustion reactions to power a lot of the stuff in our society. And if you go all the way back to where that energy comes from, most energy sources on the planet originally come out of the sun. It's maybe hard to kind of visualize that even us burning fossil fuels originally, we can't really call it solar power because the solar energy has been converted into another form of energy. But that material that we burn when we're burning fossil fuels essentially came from the sun. And I will sort of discuss that connection here today. There are very few energy sources actually on the planet that aren't related directly or indirectly to a solar influence. There's maybe two that I can think of off the top of my head. Tidal power, which we'll be discussing later on, that basically harkens to gravitational tugs between the Earth and the moon, not really related to solar energy at all, and nuclear energy, which is basically nuclear breakup of radioactive elements here on Earth. So those are two kind of forms of energy that you don't really have a connection to solar. But pretty much all the other ones we'll be discussing in this unit have at some point in their energy transfer, I guess, history, they all sort of harken back to originally solar energy hitting the Earth. And that includes the materials that we use to burn. And humans have been using combustion reactions for centuries, from everything from cooking to, powering devices. We've had a long-standing, I guess, tradition of doing this as a species. But where does that energy come from? Well, combustion reactions, you're well aware that if you take something like a hydrocarbon, something that has carbon and hydrogen atoms in it, and you connect it with oxygen, you're basically going to create a reaction that's going to create a water CO2, and you're going to release energy. But where does the energy come from when you burn these hydrocarbons? Well, initially it came from the sun, like I mentioned. Solar energy, through the process of photosynthesis, plants will take that solar energy, and we talked about this in Bio 20, if you were in my Bio 20 class, convert that solar energy into basically chemical potential energy that's found in the bonds of glucose molecules. Now, our body does it. When we take the glucose, we actually essentially do a controlled combustion reaction process called cellular respiration. That's what powers our body. Well, we can take that to a larger scale and actually burn organic material or material that once was organic, i.e. fossil fuels. And we can basically use that to basically generate energy by releasing that energy through an exothermic combustion reaction. Now, there are several ways that we can do this, as I've mentioned. One of the ways, which is the oldest one out there, is burning wood. Burning wood has been done for millennia since humans created fire and learned how to control fire. Not created fire, but learned how to control fire. It is still the least expensive and most accessible form of energy in developing countries. Burning, a tree or plant material to basically create energy. There are some issues with burning of wood. You can create or you can release what are called, might remember this from our unit, hold on here, I'm having a brain fart here. Not the last unit on electricity, the unit before that when we discussed organic molecules. I was having a little bit of trouble there remembering which unit it was. But yeah, it was Unit B where we talked about the release of what are called polycyclic aromatic hydrocarbons, otherwise known as PAHs. And they also release other pollutants because when we burn tree material or wood, these combustion reactions are not complete. So you're releasing some other byproducts that are sort of toxic, like I said, PAHs. You could also be releasing things like carbon monoxide, things that are not necessarily going to be all that pleasant. And of course, you're releasing CO2. All of these reactions are going to release CO2, which is going to contribute to the release of that greenhouse gas, which we've already as well discussed in previous units here in the course. Again, even though it does have some issues with the release of these toxic materials, it is considered a renewable resource because plants can be burned, but then you can plant new trees and they grow back within a relatively short time frame. We're not talking millennia; we're talking decades to basically get new trees. That we can then cut down again to burn. So that is an advantage of burning wood. But humans sort of advanced beyond burning of trees and plant material, and they began digging up fossilized remains of tree and plant material. And one of the first ones that humans began to basically work with from the ground was coal. And coal is formed from the remains of ancient plant life, which decomposed in tropical swampy areas and basically created what are called thick layers of peat. As the peat began to compress down into the ground, it stratified, it compressed, it got pressurized, and basically eventually became rock, or what we call now coal. And coal is one of several fossil fuels which we use, and that's why they're called fossil fuels, because they basically come from the fossilized remains of organisms that either are plants or consume plants and then obtain those chemical potential energy in their bodies. And then when they can decompose, or when they died and decomposed and got compressed into the rock, that energy was sort of stored within these fossil fuels in the soil. A couple of things about coal. And by the way, if you're interested in learning a little bit about coal, watch it. There's several videos I'm going to show you today. They're all actually very short. They're all about 2 to 3 minutes in length. Definitely worth it. Kind of an interesting little series that was put together that discusses all the different fossil fuels. But watch this video on coal just to kind of give you an idea of how coal is processed and all that. Now, in Alberta, there's been a long-standing tradition of using coal, and there's been a long-standing tradition of using coal in the industrialized world. The Industrial Revolution was powered essentially by coal, and it is still, even though the Industrial Revolution was quite a while back, we still have a heavy dependency on coal in Alberta. As I mentioned in the last video, we have a high reliance on coal to basically generate electricity in Alberta. So there's still quite a demand for coal in parts, in larger areas of the industrialized world. As I mentioned, Alberta has a rich history of coal mining. Even here in the Morinville area, there's a rich history of coal mining in the Morinville area. Areas in the province that you may have been to that were associated with coal mining, at least in the past, were Drumheller, Frank, which is down in southwestern Alberta. If you've been to Turtle Mountain, the Frank Slide, the very famous disaster that struck the town of Frank, that destroyed that town, and basically the entire mountain slid over the town because of coal mining in that mountain. Bankhead, if you've been near Banff, between Banff and Lake Minnewanka, there's the old ghost town of Bankhead there. Hillcrest is another one. Nordegg, if you've been out to Nordegg, rich history of coal mining in Nordegg. And even just here now, south of Morinville, Cardiff. You're probably very familiar with Cardiff. Cardiff mine, there was a coal mine in Cardiff back in the day. It produced almost 1 million tons of coal. And that mine operated from 1907 to 1944. And if you've been to the Cardiff Golf Course, that is the old site of the Cardiff mine. And you may have noticed there are some strange dips and contours in the golf course. If you golf that course, that is because of essentially collapsed mine tunnels below the actual golf course. So kind of an interesting history if you live here in Morinville, or even if you live in Cardiff. You may not even have known that there is essentially a very rich history of coal mining right here in our own backyard. Today, we pretty much use surface mines in Alberta is to extract coal in the province. If you've been out to areas like Seba Beach, which is on the west shore of Wabamun Lake, or Lake Wabamun, there's huge areas there that are basically being mined for coal on the surface. And then they basically will then, once they've removed the coal from underneath the ground, they will try to restore the area back to its original, I guess, glory, or what it used to look like before the mine went in. And that's a process called reclamation. And that process occurs in a lot of areas for the extraction of fossil fuels. The tar sands, the oil sands up north by Fort Mac, they're also responsible for doing that reclamation process. Once they're done extracting the oil sands from a specific area, they basically try to bring the the ecosystem back to the way it was before they were in there extracting the oil sand, which I'll get to here in a few minutes. But here's a great shot here. If you're in the notes here, you can see where they're actually mining here, and then there's these farmlands right beside it that have been completely reclaimed. They would have been areas that would have been mined before, and then they reclaimed them before they moved on to the next area where they were extracting the coal. All right, after our dependency on coal, which again we're still using, a much better form of energy came along in the 1950s, or it was before the 1950s. They were extracting oil sort of at the end of the 19th century, early 20th century, but it was the 1950s where really petroleum extraction really began to take off, and it became the world's primary fuel source. And we're still very reliant on petroleum even today. It's a liquid hydrocarbon in this case, and it's formed over millions of years from the remains of ancient microscopic marine organisms. So these are not necessarily plants, but they're single-celled organisms that basically form this liquid fossil fuel. Their decomposition over millions of years and compression creates this fossil fuel. Alberta, obviously, huge reliance on petroleum. And by the way, give this video a watch on petroleum right now, just to kind of give you an idea about, just a little bit of information about it. Alberta, our history of oil started in 1947 with the Leduc oil rig that basically we discovered oil for the first time just outside of Leduc. You can still go to the Petroleum Museum out there by Leduc. There's actually one out by Devon. Devon's got one as well, where you can actually see the old rigs and what they used to look like, and they have a lot of information about oil and oil extraction, if that's something that's of interest to you. And it's been a very lucrative industry. I mean, of late, we've had more. We've been going on some tough times with collapse in oil prices, and that's something that we're going to. And again, it's also part of the. Are we going to transition away from fossil fuels, which has been sort of talked about for many decades? At some point, are we going to end the reliance on oil? Every fuel source seems to have its day, and right now, oil is still very important. But there are trends that might, in future decades here, perhaps sway toward other forms of energy. And I'm not here to discuss whether oil is good or bad. I'm just here to say that there are other forms of energy, which again we will also be discussing as part of this unit. The Alberta-Alaska oil sands is one of the largest petroleum reserves in the world. It is relatively difficult and expensive to extract. Because it's in an oil sand form, it's not the liquid gold that people think of when you think you're drilling for oil, and the liquid oil comes right out. I mean, if you're in Saudi Arabia, you're very lucky because that's very easy and cheap oil to extract in Saudi Arabia. In other parts of the world, in our area, we have to basically extract it using surface mining, very similar to coal mining, open pit coal mines. And then we have to extract the oil out of the sand, essentially. To get an interesting view on that, take a watch of this video. This is, if you're going to watch any video today, watch this one because it does explain the whole process of the extraction of oil sands and what they are and how do we get the oil from the oil sands. But because of the extraction process, we need higher dollars for our barrels of oil than other parts of the world. So when oil prices drop, it does affect all petroleum producers, but because we have such an expensive process in Alberta, it affects us a lot heavier than other areas of the world where they can just extract the oil in a liquid form directly out of the ground. Just to give you an idea of the amount that has to be extracted, about 2 tons of earth have to be removed out of the oil sands area in order to produce 1 barrel of petroleum. So 1 barrel from 2 tons of earth. So there's a lot of work involved to get that 1 barrel of oil. Very high energy intensity. And this is, again, one of the reasons why Canada has such a high energy intensity, which I talked about in topic 1.1. Our last of the fossil fuels we'll be discussing today is natural gas. Natural gas is a mixture of hydrocarbons, primarily methane, with smaller amounts of ethane, propane, and butane in there. So it's our alkanes that are part of this natural gas, and we discussed this back in Unit B as well. Methane is extremely flammable. It is also a greenhouse gas. I may have mentioned that earlier in the course. I'm pretty sure I did, along with CO2. But it is 20 times more efficient or effective at trapping greenhouse radiant solar energy than carbon dioxide. So a couple of things. First of all, watch this this video on natural gas if you want to have an idea about natural gas. And as I just mentioned, methane is extremely flammable, holds on to heat for long periods of time. What could possibly be a problem with that? This is a kind of a cool video if you want to watch this one. This true story. You'd think this is a movie, but give this a watch about a very interesting fire that is raging right now as we speak. The gateway to hell, as they call it. Interesting one to watch. And this is sort of what happens or can happen if extraction of natural gas goes wrong. So again, watch this video if you're interested in kind of this cool little, it would be made for a TV movie, what happened in this situation. I'll let you watch that if you're interested. Two main sources of methane. There are two sources that we can get methane from. We can get coal bed methane, or we can get methane hydrate. I'll give you the description of both. Coal bed methane is basically formed during coal formation. It's sort of a byproduct. It gets trapped within layers of coal. It's removed. This kind of natural gas is removed by pumping water into coal beds and then back to at the surface. And as the water nears the surface, the reduction of pressure causes the methane to vaporize and then separate from the coal. So we basically pump water into coal to basically extract the natural gas out of the coal beds. Another form of methane, which has a lot of promise, is methane hydrate. And methane hydrate is methane that leaks from geological sediments and becomes trapped within seabed ice in the depths of the ocean. So this is methane that is found deep inside the ocean, offshore. Recent estimates state they might constitute about a third of the carbon held in all other fossil fuels combined. So it contains this form of methane that is sort of trapped in seabed ice, could be just a huge section of the overall carbon sink that is the Earth. Kind of worrisome if we begin to extract all of it, because that's going to be a lot of carbon that we're going to be releasing into the atmosphere and into the oceans if we decide to begin to extract this source of methane or natural gas in the upcoming upcoming years or upcoming decades. So interesting to keep that in mind. And that's our conversation for today. These are all the fossil fuels or combustion sources that basically all originated originally from solar energy that became potential chemical energy stored in the bonds of plants, and then it just went from there into coal or other forms of fossil fuels, or just burning trees to release energy. For your homework, I'd like you to complete the practice questions 14, 16, 18, and 19 on pages 483 to 487. And I'd also like you to complete questions 1 to 5 on page 490 of the Science 30 textbook. That's our conversation for today. Won't you join me next time when I go over 1.3 in Unit D? That's going to be harvesting chemical energy. Until then, have yourselves a great day, and we'll see you soon.